Good morning, everyone. Today we're going to be discussing time and how it is defined by the constant of pi. And the way that works is pretty simple. If you've read the book, looked at any of my other videos, you will know that in my theory, and I'll just jump ahead here, that my theory before the model that creates baryonic matter and matter in the universe as we know it starts with essentially, I'm going to keep my place here, basically starts with a black hole, which would be an alpha core, one of these alpha particles, consumes everything in existence until everything exists within that black hole and within its structure. And then it condenses to become one giant particle. So my theory of creation is actually deterioration. And the way that works is once one of these alpha cores, one of these Planck cores, consumes everything in existence and all the motion between the particles inside that core stop, then it becomes one particle, one core. And everything in existence exists within that one particle. And the laws of physics and everything else break down. The reason that I do it this way is because it becomes symmetrical. Once that splits, that one particle splits open, it creates dimensions, which then create space. And different sized particles in space creates buoyancy. And when enough small particles, right, get to a core, we call it an alpha core, Planck core, then they become denser than the particles around them, and they begin displacing the larger particles. And that is the point of the Big Bang, where matter starts forming. And that's just a quick rundown. But the cadence by which this splits has a constant, and that constant is pi. If you look at pi itself, right, it's just a circle with a line through it here. And that's the geometric visual interpretation of pi. And all I've done in order to explain the deterioration of the omega particles, the particle that forms from the black hole, the Planck core that consumes everything else in existence and then loses all of its motion between the particles, condensing it, right? The size of the particle, of any particle, as it deteriorates, as it splits, is based on the constant of pi. And so the size of the particle is exactly related to how long it takes that particle to split, to deteriorate. And that constant is pi. It's the size of the particle compared to how long it takes to split. And so if this is how long it takes to split, then it's actually time, if you think about it. And once this particle splits and begins to deteriorate, the particles get smaller and smaller and smaller in space, creating buoyant systems that eventually, again, small particles pool, create a core, and that core gains displacement, becomes denser than the large particles around it, and begins to displace larger particles. And then those larger particles are pushed outward. And this is where baryonic matter forms. So this is what we're talking about is before the Big Bang, right? And this is how we get to the point of what they would call the Big Bang, and particles beginning to form and radiate back outward under displacement from Planck cores. Now, the thing is if you take a circle like this and you split it apart and tear it and pull the two ends apart, then this center line lays down, right, and becomes the arrow of time. So if time is how long it takes this particle to split, and you tear it apart, right, separate the ends, then this center line lays down and becomes an arrow of time through the helix. And this is what we see happening from the alpha cores, Planck cores, alpha particles, moving back between, right? But Planck cores are at the center, are actually what a black hole is. So what we have here is black holes and omega particles, which means this will continue to grow until it consumes everything. It will condense again, then it will split again. And so time becomes symmetrical in my theory. Omega particles split, break down, all the way down to alpha cores, Planck cores, that then displace larger particles. That displacement happens along a helical path because Planck cores create fields. Fields radiate from a core outward. And it's pretty easy to show you here what that would look like. You get a Planck core that deteriorates, and you'll see even that the little lines of time here are pointed in, and that's because large particles out here are deteriorating to smaller and smaller particles until they become Planck cores and then start radiating back outward. So time is the deterioration of chemtron or dark matter. I say chemtron because dark matter in modern science and modern physics does not interact electromagnetically, but does interact gravitationally. And in my model, it does not have mass or interact gravitationally. So instead of calling it dark matter, I call it chemtrons or chemtron structure. So chemtron structure, the deterioration of chemtron structure, dark matter with no gravitational interaction, becomes the cadence of that deteriorating based on its size is a constant that's based on pi. And once that starts radiating outward, it happens in a helix. And again, this central line lays down and becomes an arrow of time. So time, whether you're talking about the deterioration of chemtron structure or the evolution of baryonic matter from the core outward that they would call the Big Bang, right? Their bell that you see in the Big Bang would start at this core and come straight out. And it goes in every direction, right? It doesn't just have one direction. It goes this way, it goes this way, it goes to the other side, it comes to this side. It radiates around this core outward. And what this comes to is pi is both a line through a circle, which represents the deterioration of chemtron structure, setting the cadence of time based on the size of the structure, right? Or it becomes the helical path from the core outward being the arrow of time. And either way, it represents time and is a circle. And this is the true meaning of pi and why you see it in everything. And this is where we get into some of the hard parts of defining time. See, Einstein calls his relativity space and time. And if you go back to dimensions, then you have 6 internal dimensional vectors creating 8 quadrants of space with 3 transitional planes, which I've defined in my other videos if you want to go look at. And those create orbiting standing pilot waves defined by Broglie, by Bohm, right? And these helix, starting from a core and moving outward, goes up and over that first standing pilot wave and then pulled down under and back up. And this first helix, right? The output to it, you'll see quad 1, Q1 phase, Q2 phase, Q3 phase, Q4 phase. The output to the orbital field that creates this over and under the Broglies and Bohm standing pilot waves is created, creates this helix, and these represent Maxwell's equations, which is why I know it has to be correct. Then it repeats again, which means Maxwell's equations are the only particles that can exist from a core, a density core with displacement causing outward motion in a helical path. The output is Maxwell's equations. Q1 is charge dipole. Q2 is charge monopole. Q3 is magnetic monopole. And Q4 is magnetic dipole. And what that means, basically, is that time, as represented through pi, can explain and is inherent to physics, but it's not Einstein's physics. Einstein, at the time that he lived, he worked at a patent office. People like, in Italy, I believe it was, Mussolini would have soldiers go stand behind train conductors and put a gun to their head and say, you will leave at the right time, because trains were leaving and getting into stations at different times. Different countries used different times so that you couldn't know when a train was coming. You know, someone would say, I'll be there at 4 p.m. They wouldn't get there till 8 p.m. But the time would be different in those states or countries anyway. Dealing with time was the number one problem during Einstein's life when he worked at the patent office. So he saw all of these inventions about time coming in, and his mind was on time. So when he had a variable in his physics, he called it time. But as I showed you back here, if I can find it again here real quick, right? These are accelerated dimensional vectors, these round ones, circular ones. And what it boils down to is accelerated orbital vectors become dimensions. And you'll notice that at any point where these cross, they are at 90 degree or orthogonal to the 6 internal dimensional vectors. So they are symmetrical, they don't violate symmetry in any way, and they are 4 added to the 6, creating the 10 dimensional vectors of string theory. And of course, if you have a particle in one of these and the entire particle is accelerated, and again, these are accelerated dimensional vectors. So Einstein's math goes to curved space and time. Well, this is curved dimensional vectors around the straight dimensional vectors, so we get the curved part. And the fact that they're accelerated is his time. So Einstein's time is acceleration or deceleration relative to the course. So when you hear Einstein's theories talk about relative time, they're talking about relative acceleration and deceleration. And this has been, I have proven it, I believe, because this is how that internal vector field with relative acceleration and deceleration defines, the positive and negative antiparticles defined by Dirac's equation. And again, they are simply the acceleration and deceleration relative to the system as a whole. And so Einstein's time is relative acceleration and deceleration. It is not a physical property, right? So when we use time, we use it in so many different ways that it becomes, let's say it's an hour till lunch, right? That's not a physical property of physics itself. It's just a measurement that we all agree upon. An hour is a section of time, and yet that's not physics time. It's not Einstein's time. Einstein's time is acceleration. And my time is the deterioration or the acceleration relative to the system, as defined through pi. Which you can see here. So when it comes to time, it is defined clearly as the deterioration of Chemtron structure, dark matter, or the acceleration of particles under displacement relative to the system. And if Einstein's time, which is, again, the acceleration of the particle in M theory, then we have a complete understanding of time. Why is there an arrow of time? Well, because it has to do with the deterioration of structure, right? Sets the cadence of time based on the constant of pi. And when you split that particle, right, separate it, it becomes a helix, and that line in the center lays down, and this becomes, from a core outward, somewhere here, this helical path outward from the core, okay, the line of time from the center. And so this is, again, even though I don't call it the Big Bang, and I don't like the term Big Bang, if this is accelerated cores, right, and I say that that's the Big Bang radiating in any direction, that those cores start the creation of baryonic matter, okay, they get pushed in, they get accelerated back out, and when they come out, they have an inverted antipole around the Chemtron structure, which is what becomes baryonic matter, which gives it mass and charge relative to the system. And so this Big Bang is, they say the universe is 13.7 billion years old or something. Well, that is the radiation from the center of that core through the arrow of time, leaving, the core outward. So you get the arrow of time when you begin baryonic matter, which is what physics is defining right back to what they call the Big Bang, and I call the Planck core, radiating, accelerating particles. And when they begin their acceleration from the Planck core, they gain charge and an inverted antipole atmosphere that gives them mass. And, well, that's the beginning of gravity. And should prove to you that gravity is a local force, not a universal force. This is time. This is the cadence of time based on the deterioration of Chemtron structure by the constant of pi. And that's it.